Number 1, we have here that B is 7.44. Measure of angle A is 41 degrees. The directions were to solve the triangle, which means find the missing measures. So one answer, real easy. Measure of angle C. The picture clearly shows it's 90 degrees. We could use cosine to figure out what angle C is, what side C is. And the reason we have, starting with our acute angle 41, we have the adjacent leg and we have the hypotenuse. So the adjacent leg and the hypotenuse relative to 41 degrees is cosine. So cosine of our angle equals the adjacent leg divided by the hypotenuse. Trying to solve the equation, we're trying to get C by itself. Right now, C is in a fraction. So to get rid of our fraction, we need to multiply both sides by the bottom of the fraction. So that's times C. So we have C times cosine, 41 degrees on the left. On the right, your C's cancel because you're dividing and multiplying by the same thing. Canceling meaning you have a 1 left. So it's 7.44 times 1, which is 7.44. To get C by itself completely, you divide both sides by cosine of 41 degrees, which I'm just going to show that here. You don't have to show this. I typically don't. Which gives us then, on the left, C, because your cosine of 41's cancel. On the right, 7.44 divided by cosine 41 degrees. Put this in your calculator to the nearest tenth, is what the directions say. To the nearest tenth, this is 9.9. Because you get 9.85, and the 5 rounds the 8 up to a 9. So we have side C, and we also have angle C. We got both of those things done. We need to figure out what A is and angle B. This 9.9 that we just found for C, we do not want to use that number again. It's rounded. If we use that number to find other answers are going to be slightly wrong. So I'm only going to use the red numbers unless I can't avoid it. I can avoid it. Let's find a measure of angle B. That should be pretty easy. Measure of angle B plus 41 degrees has to be 90 degrees. The two complementary angles in a right triangle have to sum to be 90. I think I just said something redundant. The two acute angles, which is angle B and angle A, in a right triangle, those have to add up to be 90. If I subtract 41 from both sides, we get the measure of angle B. It's 49 degrees. Now that number is not rounded. If we wanted to use 49 degrees to figure out what A was, then we could. So several options to finish this off. I'm just going to mention a couple of them. We could say tangent of 41 equals the opposite, which is A, over the adjacent leg, which is 7.44. That's one option. Another option, we could say tangent of 49 degrees is the opposite leg, 7.4, over the adjacent leg of A. Either way, we're going to get the same answer. If we didn't care about the rounding error, which once again 9.9 is rounded, so it's slightly wrong, we could use the Pythagorean Theorem, A squared plus B squared equals C squared, to figure out what A was. Once again, we don't want to do that because 9.9 is slightly wrong because it's rounded. Let's do tangent 41 degrees equals the opposite leg, which is A, over the adjacent leg, which is 7.44. To get A by itself, you multiply both sides by 7.44. On the right side, your 7.44s would cancel, meaning you get 1 as a result. left side, you get 7.44 tangent of 41. Put that in your calculator to the nearest tenth, you get 6.467. So 6.46 makes it round to 6.5. And this is an approximate answer, so it's best if you use an approximate sign. So it's kind of a mess, my work here, but you can see we figured out what the missing. Number 2, we're given that side A is 9 and the angle B is 42 degrees, 10 minutes. Obviously, once again, measure angle C is going to be 90 with no work because the picture shows it's a 90-degree angle. So that part's done. Angle A, that should be pretty simple to figure out. Measure of angle A plus the other acute angle have to add up to be 90 degrees. That's true in every right triangle. Subtract 42 degrees in 10 minutes from both sides. I'm going to erase this work here, but let me show you how to figure that out. 90 degrees minus 42 degrees, 10 minutes. Old school subtraction. I'm trying to take 10 away right now from 0 minutes. You can't take 10 from 0, so you borrow from the 90. Borrow 1. 1 degree is equivalent to 60 minutes. So 89 degrees, 60 minutes, same as 90 minutes. 60 minus 10 is 50. 89 minus 42 is 47. So we get 47 degrees, 50 minutes. So we found the measure of angle A. Now that answer is not rounded, so we could use that number to find other answers if we wanted to. I'm not going to put it in my picture just because the picture is so small. It's just going to get real sloppy. Let's say we want to figure out what side B was. So relative to 42 degrees in 10 minutes, side B is the opposite leg. Side A is the adjacent leg. I want to use A because it has a number, 9. Anytime you make an equation, you're hoping to only have one variable. So what trig function uses both legs? That's tangent. So tangent of 42 degrees, 10 minutes, equals the opposite leg over the adjacent leg. That's B over 9. Trying to get B by itself, we're going to multiply both sides by this denominator. That breaks my fraction apart. So on the left, we get 9 tangent, 42 degrees, 10 minutes. On the right, we get B. Multiplying and dividing by 9 gives us 1. B times 1 is B. You put that in your calculator, you get 8.15 to the nearest tenth. That's 8.2. It's rounded. If we can avoid using that number for other answers, let's avoid it. So to find C, going back to this original angle, we have this acute angle, we have the adjacent leg, we have the hypotenuse. That's cosine. Cosine 42 degrees, 10 minutes, equals the adjacent leg over the hypotenuse. To break the 9 and the C apart, we're going to have to get rid of the dividing by C. So we're going to multiply both sides by C. On the left, then, we get C times cosine of 42 degrees, 10 minutes. On the right, our C's cancel. C divided by C is 1. 9 times 1 is C. 9 times 1 is 9. To get C by itself completely, we want to get rid of the cosine of 42 degrees, 10 minutes. So we divide both sides by it. So that gives us C equals 9 divided by cosine 42 degrees, 10 minutes. Calculator gives me approximately 12.14 to the nearest tenth. That's 12.1. So we got 4 answers. Angle A, side B, side C, angle C. So we've completed the problem. Number 3, given angle B and side B, got to find all the other missing measurements. Angle C, once again, is 90. Picture shows that. No work to be shown for it. Angle A, pretty simple. The two acute angles in a right triangle have to sum to 90 degrees. So to figure that out, we take 90 degrees and we subtract 22 degrees, 22 minutes. You can't take 22 away from nothing, so you have to borrow from the 90. There are 60 minutes in a degree. 22 from 60 is 38, and 22 from 89 is 67. So we get the measure of angle A is 67 degrees, 38 minutes. Let's see what we can do now. Starting with our acute angle, we're going to be using this B every time. That's the opposite leg. If we wanted to figure out what C was, we would use tangent, because the opposite leg and the hypotenuse, which is what C is, that's sine. If we wanted to figure out what A was, we would use tangent, because we have the opposite leg and the adjacent leg. So let's figure out what A is first. Tangent of 22 degrees, 22 minutes equals the opposite leg over the adjacent leg. If you multiply both sides by A, that breaks this fraction apart on the right. We're trying to get A by itself. On the left, we get A tangent 22 degrees, 22 minutes. On the right, if you divide something by itself, which is what the A's are happening there, you get 1. 22 divided by 1, or 22 times 1 is 22. To get A by itself completely, we divide both sides by what's attached to the A. A is attached to tangent by multiplication, so we divide both sides by tangent of 22 degrees, 22 minutes. Tangents cancel on the left. We get A. On the right, we get 22 divided by tangent of 22 degrees, 22 minutes. To the nearest tenth, get 53.5. Figure out what C is, we could use sine. Sine of our acute angle, 22 degrees, 22 minutes, equals the opposite leg, 22, over the hypotenuse, which is C. You multiply both sides by C to break the fraction apart on the right, and then divide both sides by sine of 22 degrees, 22 minutes. You get C is 22 divided by sine of 22 degrees, 22 minutes. Using a calculator, that comes out to be approximately 57.8 to the nearest tenth. Number 4, once again, measure of angle C is 90. Picture shows that little box for angle C, so it's 90 degrees. And I left off my C here. Measure of angle C is 90. To figure out B for this problem, side B, we could simply use the Pythagorean Theorem. a squared plus b squared equals c squared. A is 21. Don't know what b is. C is 30. 21 squared is 441. 30 squared is 900. If you subtract 441 from both sides, you get b squared is 459. If you square root both sides, you get plus or minus. But since we are talking about length of a side of a triangle, the answer is going to be plus. This is going to give us approximately 21.4. That's what side B is. We do not want to use that number, 21.4, to find other answers, because that answer is slightly wrong, because we rounded it. Let's say we wanted to figure out what angle B was. Relative to angle B, we have the adjacent leg and we have the hypotenuse. That's cosine. So we're going to say cosine of angle B equals the adjacent leg over the hypotenuse. Right now we are trying to get B by itself. B is attached to cosine by cosine. To unattach it, you must do cosine inverse. If you do it to one side of the equation, you got to do it to the other. On the left, since you have inverse operations, cosine and cosine inverse cancel. So on the left, we just have B. On the right, we have cosine inverse of 21 over 30. Put that in your calculator. You get B is 45 degrees, 34 minutes. Let me just point something out here real quick. When you put this in your calculator, you end up with 45.572996 degrees. The directions say we want to the nearest minute. So 45 is our whole degrees. We have to convert this decimal to minutes. So to do so, you don't have to show any of this work. I'm just trying to explain it. We need to multiply this by 1 so we don't change its value. We need to disguise the 1 so that we can get it to be in minutes. 60 minutes in a degree. So we want to get rid of the degrees. I put 1 degree on the bottom, 60 minutes on top, the degrees cancel. In essence, you're just multiplying the decimal by 60. That's the point. If you do that, you get 34 point something. It just rounds to 34. Lastly, we have angle A. I'm going to kind of contradict myself a bit here. I've said not to use the rounded answer to find other answers. But there's also a fact that the 3 angles in a triangle have to add up to be 180. Or you could be a little bit more specific and say the 2 acute angles have to add up to be 90. So for this to make any sense, to figure out angle A, I'm going to use angle B. Because I want for sure my angles to sum to be 180. If I take those 2 acute angles, they have to sum to be 90. If I subtract 45 degrees, 34 minutes from both sides, if I do that, I get 44 degrees and 26 minutes. Now, it's possible, since these are rounded, if someone else had done this problem and they had found angle A first, using trig, they might have got 44 degrees, 25 minutes for angle A. If they did, then they would have got for measure of angle B 45 degrees, 35 minutes. The point is, since we are rounding, you can get slightly different answers and still have done it correctly. But it's also possible that you could do this problem and get a slightly different answer and have done it incorrectly. But here's a case where you could have these answers as well, as long as your work supports it, that it wouldn't be counted wrong. Number 5 here is real simple. Once again, measure of angle C is 90 degrees. It's a right angle. If C is 7 square roots of 2, and A is 45 degrees, obviously this is a special right triangle, 45, 45, 90. If opposite 90 is 7 square roots of 2, opposite 45 has to be that number divided by the square root of 2. So these are 7s. This all goes back to memorizing your special right triangles. Opposite 45s, we call it alphas. You can call it whatever you want. Opposite 90 is that same number times the square root of 2. It fits this here. So 7 is opposite 45. Therefore, opposite 90 is that number times the square root of 2. So this problem is over before it started. This next problem, once again, measure of angle C with no work. It's a right angle. It shows the little box down there. It means it's 90 degrees. Side B, we could use the Pythagorean Theorem. A squared plus B squared equals C squared. A is 31.2. Don't know what B is. C is 42.4. Using a calculator, 31.2 is 973.44. C, 1797.76. If you subtract 973.44 from both sides, you get 824.32. If you square root both sides, you get B is plus or minus 824.32. B is the length of a side. Therefore, it's just the positive answer. B is approximately 28.7. To figure out what angle B is, or angle A, either one, we could use a trig function. Doesn't matter which one we find first. Let's say that we do angle A. Measure of angle A. We have A is the opposite leg and C is the hypotenuse. That's sine. Sine of angle A is the opposite leg over the hypotenuse. To get A by itself, A is attached to sine by sine. To unattach it, you need the inverse of sine, also known as sine inverse. If you do it to one side, you got to do it to both sides. On the left, two inverse operations cancel. On the right, you get sine inverse of 31.2 divided by 42.4. Put that in your calculator and you get angle A is 47 degrees, 23 minutes. Calculator actually gave me 47.379, yada, yada, yada. 47 is the whole number, that's the minutes. If you take the decimal, the 0.379, and you multiply it by 60, it changes it to minutes. That's how I got 23 minutes. All the angles in a triangle add up to 180. The acute angles in a right triangle add up to 90. So if I take angle B, its measure, and add it to angle A's, it has to equal 90 degrees. The two acute angles of a right triangle have to be complementary. I subtract 47.23 from both sides, and I get the measure of angle B. Gives me 42 degrees, 33 minutes. 37 minutes. It is possible that if you figured out angle B first, using trig, that this 37 might be off by 1, might be 36 or 38, which in turn would make angle A off a different degree. If you did that, that's still right. But if you did it in the order that I did it in, then we would consider this to be the correct answer. Problem number 7 says we have a regular pentagon. Pentagon has 5 sides. All sides are the same length if it's regular. Has an apothem of 7.43 centimeters. Apothem goes from the center to the side, cutting it in half, also forming a 90-degree angle. This apothem, 7.43 centimeters. And the question is, find the length of a side of the pentagon and the length of the radius. So we need to find the length of this red segment and also find the length of this green segment, the length of the side. So this looks like it's really difficult, but it really isn't that difficult. First thing you want to do is find the measure of a central angle. To find a central angle, simply take 360 degrees and divide it by how many sides you have. We have 5 sides. .360 divided by 5 is 72. So the central angle is 72 degrees. An apothem will always cut a central angle in half. So if we draw a central angle with 2 radii, and it's cut in half, each half has to be half of 72, which is 36. Let me take this triangle here. Let me redraw it down here a little bit bigger. So we have this 90-degree angle. We have the apothem of 7.43 centimeters, I believe. And we have that this angle up here is 36 degrees. So the question is, what is the radius? This picture, the radius would be right here, which in this triangle we reveal would be the hypotenuse. And also, what's the length of the side of the pentagon? Well, if we find the length of this side down here, x, that's half the length of the side, because it takes 2 of those x's to make up the whole side. To figure this out, we're going to use right angle trig. So starting with our 36-degree angle, starting with that acute angle, we have the adjacent side 7.43, and we have the hypotenuse r. So we could say cosine 36 degrees equals the adjacent leg over the hypotenuse. To solve this equation, we're going to multiply both sides by r. If you multiply the right side by r, that gets rid of the dividing by r. If you multiply the left side by r, you get r cosine of 36 degrees equals 7.43. To get r by itself completely, you have to separate the r from cosine of 36. It's attached by multiplication. The opposite of multiplying is dividing. So if we divide both sides by cosine of 36 degrees, on the left, if you divide something by itself, you get 1. On the right, you're going to use your calculator to figure out what's 7.43 divided by cosine of 36 degrees is. This is going to give us an approximation for r. When you put it into your calculator, make sure you're in degree mode. To the nearest hundredth, I got 9.18 centimeters. Hundredth is 2 decimal places. So that's what r is. It's the radius. Got that part finished. To figure out what x is, we're going to also use trig. Compared to the 36 degrees, x is the opposite leg, 7.43 is the adjacent leg. And we just use another sheet here to do that. So we take tangent of 36 degrees equals the opposite leg over the adjacent leg. To get x by itself, we have to get rid of the dividing by 7.43. So we're going to multiply both sides by 7.43. On the right, the 7.43's cancel. Something divided by itself is 1. On the left, we get 7.43 tangent of 36 degrees. Put that in your calculator. Make sure you're in degree mode, and you should get to the nearest hundredth, 5.40. Now, that 5.40 is not the length of a side. If you look down here, it's x, which in turn is half the length of a side. So, answering the question, find the length of a side. The length of side is going to be 2 times 5.40, which would be 10.80 centimeters. In the second part, find the length of the radius. Radius is the red and orange segments in this picture up above, which we found to be 9.18 centimeters. Number 8, we have a rectangle. One side is 17.5 centimeters. The other is 26.2. A rectangle has 90-degree angles. Opposite sides are the same length. Opposite sides are parallel. Diagonals are the same length. Find the angle formed by the longer side. This right here is the longer side. 26 is bigger than 17. Find the angle formed by the longer side in the diagonal to the nearest minute. A diagonal is a segment that connects 2 non-consecutive vertices. So this red segment is the diagonal. Once again, it says find the angle formed by the diagonal. It's the red segment. And the longer side. So it's referring to this angle right here, which we'll call alpha. So it's saying, figure out what alpha is. Tangent of alpha equals the opposite leg over the adjacent leg. To get alpha by itself, you have to get rid of tangent. Tangent attaches itself to alpha by tangent. To get rid of tangent, you have to do tangent inverse to both sides of the equation. On the left side, your tangents cancel, leaving you with alpha. On the right side, you have tangent inverse of 17.5 over 26.2. If you type that into your calculator, you end up with 33.74 and some stuff after that. The direction says to the nearest minute. So we got 33 whole degrees. If you take the decimal you get from your calculator, which was 0.7405 and some other stuff, if you multiply that by 60, you don't need to show this work, by the way. If you multiply that by 60, that's going to give you how many minutes this is. It ends up being 44 minutes. So the question, what is the angle formed by the longer side and the diagonal? It's 33 degrees, 44 minutes. The 7.4 centimeter chord. A chord is a segment that intersects a circle in two places. So this purple segment here is a chord. It's 7.4 centimeters. It subtends a central angle of 41 degrees. What that means is, if you draw a central angle from the same endpoints, like so, the central angle right here is 41 degrees. Find the length of the radius of the circle to the nearest hundredth. So it wants us to find this length right here. This problem is the same as other problems that we've done. It just looks different. What you have here, since these are both radii, these are both the same length, which means this triangle that you see here is an isosceles triangle. So this isosceles, if we were to draw an altitude through here, it would do three things. It would make a 90-degree angle, would cut this side in half, and would cut this angle in half. Let me redraw one of those triangles down here so it's not so confusing. If this side was cut in half and it was 7.4, you take 7.4 and divide it by 2, you get 3.7. So this side is 3.7. 41 degrees was the central angle. If you divide that by 2, you get 20.5. So here we have a right triangle. We have an acute angle. We have the opposite side. We want to figure out what the radius is, the hypotenuse. So it's just a simple right angle trig problem. Sine of 20.5 degrees equals the opposite leg, 3.7 centimeters, divided by the hypotenuse, which is r. If you multiply both sides by r, to separate the r from the 3.7, then divide both sides by sine of 20.5 degrees, you get r equals 3.7 centimeters divided by sine of 20.5 degrees. I'll put that in my calculator, making sure it's in radians, pardon me, making sure it's in degrees, not in radians. You get that this radius, it says to the nearest hundredth, 10.57 centimeters. So that answers that question, 10.57 centimeters. Question 10. Derive two formulas for the length of the altitude of the triangle shown at the right. This orange segment is the altitude. Altitude means it forms a 90-degree angle with the opposite side and goes through the vertex angle. C is the vertex angle. Given that A, B, and the measure of angle A are known, justify each step and that you take in your reasoning. So we know what A is, little a. I'm just going to put a box around things that we know. We know what side B is, and we know what angle A is. We don't know what angle C is, we don't know what angle B is. We're supposed to derive a formula for the length of the altitude. Let's call this altitude x. So, how can we figure this out? Well, if you look at this triangle on the left, this triangle here, this gray triangle, we have a right angle, we have an acute angle A. We don't know what it is, but we know what it is. Because it says we know what it is, but we don't really know what it is. Think about that. We know that the hypotenuse of this triangle is A, and we want to know what x is. It's pretty simple. Sine of angle A equals the opposite leg, x, over the hypotenuse A. It says derive a formula for x. We want to get x by itself. Multiply both sides by A. You get A times sine of A equals x. I use that variable x. I really should say what x stands for. It's called defining your variables. X is length of altitude. All right, so that's one formula. This one right here. This is our official answer. Can we find another? Going back to this gray triangle, if this bottom length here is B, this altitude in an isosceles triangle, this is isosceles because both of these legs are the same, they're both A, makes this half of B. Always going to cut this side in half. An altitude will always be a median in an isosceles triangle. So, using A, half B, and x, we could use this formula. Cosine of angle A, we know what angle A is, the directions told us that we do, equals the adjacent leg, half of B, over, and I messed that up. Don't want to use cosine. Please forgive me. Starting at A, we have the adjacent leg, half B. We want to figure out what x is. X would be the opposite leg. So let's go with tangent. Tangent of angle A is the opposite leg, which is x, divided by the adjacent leg, which is 1/2 B. To get x by itself, we could multiply both sides by 1/2 B. That gets us 1/2 B times tangent of A equals x. We've already defined x as the altitude, so this is our second equation. There's more than just two. There's two possible answers for this. Question 11. Mrs. James using a 6-foot ladder to clean the windows on her second floor. So here we have a house. Here we have a ladder. The ladder is stretching up and it's touching the house on the second floor. Here's the ground. It's a 6-meter ladder. The ladder is 6 meters. Her ladder stands on level ground and rests against the side of her house at a point 4 meters above the ground. So that means that this vertical distance here is 4 meters. And I need to choose a color that you can see. How far from the side of her house is the foot of the ladder? This is the ladder. Here's its foot. So it's asking, what is this length right here? Pythagorean Theorem would answer this question nicely. X squared plus y squared equals r squared. So x squared plus 4 squared equals 6 squared. 4 squared is 16. 6 squared is 36. X squared is 20. It says to give a rounded answer. Square root of 20 to the nearest hundredth is 4.47 meters. 12. A hot air balloon rises at a rate of 70 feet per minute. Let me write that down. Rises 70 feet every minute. An observer 420 feet from the place of ascent watches the balloon rise. Here's what that means. This balloon's in the air, spongy. Here's the ground. SpongeBob vertical to the ground would be his height, and the observer, from where that hits the ground, if we go off to the right or left, this observer is 420 feet away. Let's say the observer is Patrick. 420 feet. A. Write an expression for the altitude of the balloon in terms of time, t minutes, in the angle of elevation, theta. Angle of elevation starts at a horizontal and elevates. Relative to Patrick, we have this angle of elevation, and it says that's theta. The height of this balloon, every minute, it rises 70 feet. After 1 minute, it's 70 feet high. 2 minutes, it's 70 times 2. 3 minutes, it's 70 times 3. This height, this altitude, is just 70 times t, where t is the number of minutes. So question A, write an expression for the altitude. 70t is the altitude, in terms of t minutes in the angle of elevation, theta. So we could simply write tangent of theta, this is part A, equals the opposite leg, 70t, divided by the adjacent leg, 420. That is good enough for part A. If we knew what theta was, and we knew what t was, or either one of the two, then we could find the other. We could find t if we knew theta, we could find theta if we knew t. So that's part A. Part B is a completely different question. What is the altitude of the balloon after 3.5 minutes? Well, this was pretty simple. Altitude is just 70t. So if t is 3.5, you take 70 times 3.5. Which is 245 feet. After 22 minutes, it's the same thing. I put a 22 in for 70. Seventy times 22 is 1,540 feet. And then the third one after 1 hour. Notice t is defined in minutes. So when you do this third part, you have to convert hours to minutes. There's 60 minutes in an hour. It's 4,200 feet. So there's part B. Part C, which I'm running out of room here, I'm just going to erase this to give myself some more room. Part C is saying, take each of those answers that you got from part B and figure out what the angle of elevation is. Should be pretty simple. So the first one here, if we take tangent of alpha, tell you what, let's do this first to make this simpler. Tangent of alpha is, let me drop down here to save myself some space. If I get theta by itself here, I would get theta equals tangent inverse of 70t divided by 420, where 70t, once again, is the altitude. We've defined that as that. Therefore, when I'm doing these problems, just to make it, because I don't have a lot of room, I could say that theta is tangent inverse of my altitude, that's what 70t is, divided by 420. Part C. So the first part of C, let's call this CI. Don't know why. We would take theta is equal to tangent inverse of 245 divided by 420. If you take tangent inverse of 245 divided by 420, says to the nearest minute, we get 30 degrees and then 0.256, yada, yada, yada. Take the decimal of that and multiply it by 60. You get 15 minutes. Part C, II. No idea why I'm using IIs. Same thing, but we use 1540. So theta equals tangent inverse 1540 divided by 420. Put this in our calculator. It should be in degree mode. It ends up being 74 degrees, 45 minutes. you do third part, I am just running all kinds of space here. This is getting embarrassing. Take 4,200 divided by 420. Stick that in your handy dandy. It's 8417. So there's all of our answers for 12. I'm sorry that it's all crammed together. Peace and love. To find the height of the Charles Mount in Illinois, Jim located 2 points C and D on a plane in line with the mound. Let me just take a moment here and do a quick search on Charles Mound, and we'll put that picture in here. Well, here's what I came up with. I searched Charles Mound and I got this dude holding a sign. So this mound is on the ground. Let's call this the ground. It's supposed to be level. And I hit my body when I was drawing that. So to find the height of this mound, and let's say the mound goes up like this. Jim locates 2 points C and D in line with the ground. So let's say we got these 2 points here, which are C and D. I'm not sure which one is which at this point. Yes, I do. We got C and D. I'll explain why I know C's in front in a moment. The angle of depression from the mound to C, so from the top of the mound, we're going to draw this segment to C. Angle of depression is 26 degrees, 27 minutes. Angle of depression starts at a horizontal. So I'm starting at the top of the mound. I need an imaginary horizontal. So this angle of depression, 49 degrees, 42 minutes. And the angle of depression to D, so I have another one of these going to D, that's 26 degrees, 27 minutes. Jim reads on Google that the mound is 1,235 feet high. So this height here is 1,235. Find the distance from C to D. So a couple of things. One, since this imaginary horizontal line up here, the dashed orange one, since it's horizontal and the ground's horizontal, those are parallel to each other. Since they're parallel to each other, that makes these angles alternate interior angles. So this angle here is the same as this angle here. This angle here is the same as this angle here. So I can clean this up a bit, and I'm probably going to just erase most of this. So basically we have two triangles. We have this one here. This is 1235. This angle down here is 49 degrees, 42 minutes. And I have this bigger triangle. And this angle is 26 degrees, 27 minutes. Hope you can see where this is going. If we figure out what this value is from the bottom of the mound to C, and we figure out what this value is from the bottom of the mound to D, so essentially in this picture, let me try to clean this up a little bit. If X goes to here, and Y goes to here, figure out the distance between C and D, we're just going to subtract X from Y. So let me see if I can draw this a little bit better. All right, I got this drawn a little bit better. I mentioned earlier I'd say how I knew C was closer than D. This 49 degrees, 42 minutes, the bigger the angle is, the closer you are to whatever you're looking at. If you imagine yourself walking and you're staring at something that's high, the closer that you get to this, the more your head has to tilt up to see it. And the further back you are, the less you have to tilt up, because it's a gradual increase. So the closer, the bigger the angle, and the further you are away, the smaller the angle. That's the point. So to do this problem, you're going to figure out what x and what y are. Both of them are going to be using tangent. So in this first triangle, the smaller one, the 12, 35, let's say this green one, this green triangle. Starting with our acute angle, we have the opposite leg and we have the adjacent leg that we're trying to figure out. So that's tangent once again. So we can say tangent of 49 degrees, 42 minutes equals the opposite leg over the adjacent leg. We multiply both sides by x to separate our fraction, and divide both sides by tangent of 49 degrees, 42 minutes. And then put this in our calculator. This is approximately 1,047.36 feet. That's what x is. Figure out what y is. We look at this bigger triangle. It's the same equation we just used, but instead of 49 degrees, 42 minutes, we use 26 and 27. So we get tangent 26 degrees, 27 minutes equals the opposite leg of 1235 over the adjacent leg of y. We are looking at this blue triangle. The more I write on this, the more messy it gets. In the blue triangle, we have this acute angle, the opposite leg, and we're trying to figure out the adjacent leg of y. Let me erase all that junk I just threw up there. So multiply both sides by y to separate your fraction. Then divide both sides by tangent of 26 degrees, 27 minutes. Put that in your calculator. And it's approximately 2482.45. So the distance from C to D is going to be 2482.45 minus the 1047.36. Directions say to the nearest foot. To the nearest foot, it's 1,435 feet. Sorry, I crammed so much stuff onto one problem. 15. Find the bearing of a road that runs directly from A to B, with B being 3 miles north and 1.7 miles east of A. So here we have A. If we go north, let's assume north is in this direction. If we go north 3 miles, and then east 1.7 miles, that takes us to B. But it's saying that this road goes directly from A to B. So this purple thing here is the road. It says find the bearing of the road. And then it defines what that is in the second sentence. That bearing of B from A is the positive angle with a vertex at A measured clockwise north to B. So that would just be this angle right here is what it's referring to. So we would use tangent of angle A, and it is the opposite leg, 1.7, over the adjacent leg, 3. If you apply tangent inverse to both sides to separate the tangent from A, that gets you A by itself. Put that in your calculator. It ends up being approximately 29 degrees, 32 minutes.